Welcome to another episode. Today we are going to be solving the try work I gave the last time. So let's start. The first question was, find a solution to this problem. Okay, so as I said yesterday, when you are being given such a question, you first have to check for the GCD. So now let's check for the GCD of 143 and 374. Now, for us to know the GCD of this, we have to use the Euclidean algorithm. So we start by doing this, 374. So this, which is the bigger number, is equal to this. So 143. So how many times will 143 go into 374, which is 2 times plus a remainder of 88. Then we write this as the next one. So 143 is equal to, over here we bring the remainder, so 88. How many times will 88 go into 143? So once, plus a remainder of 55. Again, we write the 88 is equal to the remainder. How many times will it go? Once, plus 33. 55 is equal to 33 plus 1, then plus 22. 33 is equal to 22 plus 11. Then 22 is equal to 11 times 2 plus 0. If you remember, I said whenever you do the Euclidean algorithm, the last non-zero number that you get is your GCD. So in this case, our GCD is 11. So the GCD of 143 and 374 is equal to 11. Now, after getting this, if you want to see if a solution to this exists, you have to check if 11 is a divisor of 17. Now, since 17 is a prime number, it has only two divisors, which is 1 and 17 itself. So there is no way 11 can be a divisor of 17. So the GCD of 143 and 374, which is equal to 11, is not a divisor of 17. So there is no solution to the problem. Okay. So with the second part of question 1, the question was 287 modulo 945 multiplying x, and this is equal to 35. So in Z 945. So then again we have to find the GCD. So what is the GCD of 287 and 945? So we have to go through the Euclidean algorithm again. So 945 will be equal to 287. And how many times will 287 go into 945? And that is 3 plus a remainder of 84. So 287 is equal to 84 times 3, then plus 35. 84 will be equal to 35 times 2 plus a remainder of 14. And 35 will be equal to 14 times 2 plus a remainder of 7. And 14 will be equal to 7 times 2 plus a remainder of 0. So the last non-zero element over here, or a number over here, is 7. So meaning that the GCD of 287 and 945 is equal to 7. And if you recall yesterday, we said for a solution of this kind to exist, the GCD should be able to divide whatever is over here. So we had something like the GCD, if we have an equation of this sort, AN and B is equal to C. So we had, if we have this, AX plus BY is equal to C, then the GCD of A and B should divide C. So in this case, we can see that the GCD of A and B is 7. So let's check that 7 divides C, which is 35, or is 7 a divisor of 35? So indeed, we can see that 7 is a divisor of 35. So the divisors of 35 are 1, 5, 7, and 35. So indeed, 7 is a divisor. So now, since 7 is a divisor, then it means that a solution to this problem exists. Now, if a solution to this problem exists, how do we find it? That is when we start solving this equation backwards. So let's do that over here. Sorry. Okay. So we always start from the last non-zero element or number. So in this case, let's make 7 the subject. In making 7 the subject, we're going to get 7 is equal to 35, which is always multiplying 1, minus, if this over here crosses the equal sign, we're going to get minus 14 and 2. Now, we are done with the first remainder. Let's move on to the second remainder, where we make 14 the subject. We make this 14 the subject, okay? So we're going to get this. So 35, 1. And we are making this 14 the subject. So we are going to get 84, which has 1 already, minus 35, 2. And there is this 2. So we just bring it. Okay. Now, if we expand this, we are going to get 35, 5. So we're going to get 35, 5, minus 84 times 2. Okay. So we move on to the next remainder, which is 35. So the next remainder, we are going to get 7 is equal to 287, which has 1 already, minus 84 multiplying 3, then all multiplying 5, minus 84 multiplying 2. So 7 will be equal to 287 times 5 minus 84 times 17. Okay, then let's move on to the last remainder. The last remainder is 84. So let's plug it in. So 7 is equal to 287 times 5 minus 84. When you make 84 the subject, you're going to get 945, which has 1, minus 287, which has 3. Then you bring this 17. So times 17. So if we expand this, you're going to get 287. We have 5 over here. 3 times 17 is 51. So we are going to get 56 minus 945. 1 times 17 is 17. Okay. So when you have this equation right here, when you have this, you know that this can be rewritten as, we can resolve this equation as 287x plus 945y is equal to 35. And if you compare this equation to this, you can clearly see that there are some similarities, right? Okay. Now what we are going to do is When we get over here, because 7 was a divisor of 35, we have to multiply this 7 by 5 to get, we have to multiply this 7 by 5 to get this 35. So we are going to get 35 is equal to, then we multiply whatever it is in the bracket by 5. So 56 times 5, we are going to get 280 minus 945. 17 times 5 is 85. Now, after getting this, don't forget that everything is in modulo 945. The question gave us everything in modulo 945. So in this case, we can write this as 287 modulo 945 times 280 minus 945 modulo 945 times 85. Now, over here, 945 times 85 modulo 945 will always give you 0. Since this and this are the same, you are always going to get 0. So our equation will be left with 287, 945, 280 is equal to 35. And if you compare this equation with this, you can clearly see that our x is equal to 280. So if we put this back into it, if we have 287, 945 multiplying 280 is equal to 35. So if you multiply 287 by 280 and you find the modulo in 945, you should get 35. Now, what if we want different answers? You remember the last time you got to see that if you want to see the number of solutions that will satisfy this particular equation, you have to find the GCD of A and N. So in this case, if we know that the GCD of 287 and 945 is equal to 7, which implies that we have 7 different solutions. Okay, so now that we have 7 different solutions, remember that the last time we got this, sk is equal to x naught, plus n over the GCD of A and N multiplying t, where t belongs to 0, 1, then to the GCD of A and N minus 1. So our t will belong to 0 and 1. And the GCD of A and N is 7. So 7 minus 1 is 6. So 2, 3, 4, 5, 6. So that our first S, the one that we had was x naught, which is equal to 280. So if you plug that one in, you're going to get sk is equal to 280 plus our n is the modulo, so 945, over the GCD, which we had 7, multiplying t. So we are going to get sk to be equal to 280 plus 135 t. Okay, so now when t is equal to 0, we are going to get x naught to be equal to 280 plus 1350, so 280. If t is equal to 1, we are going to get x1 to be equal to 280 plus 135 times 1, and that is 415. Remember, everything is in modulo 945. Now when t is equal to 2, I'm going to get s2 to be equal to 280 plus 135 times 2, and this is going to give us 550 modulo 945, and that is equal to 550. When t is equal to 3, I'm going to get 685 modulo 945, and that is 685. When t is equal to 4, we are going to get 280 plus 135 times 4, and that is 820 modulo 945, and that is equal to 820. Now when t is equal to 5, 280 plus 135, 5, and that is equal to 955 modulo 945, and that is equal to 10. Note, this value over here is bigger than this. So if you find the modulo, the remainder, so 945 will go into 9551, remainder 10. Now when t is equal to 6, x6 will be equal to 280 plus 135 times 6, and that is equal to 1090 modulo 945, and that is equal to 145. So the x values satisfying the equation, we have these are, so these are the s values satisfying the equation, meaning that if we have this 287, if we have 287,945, then any of these x values, say 685, we should be able to get 35 in Z945. So this is the solution to question 1b. Now let's move on to question 2. Question 2, we were given 644x plus 1477 y is equal to 7651. So we are asked to find the set or a pair of x and y that will satisfy this positive pair of x and y that will satisfy this. So we will go through the normal routine that we've been going through. So first of all, check for the GCD. So what is the GCD of 644 and 1477? So using the Euclidean algorithm, so 1477 is equal to 644 times 2 plus 189. Okay, so 644 will be equal to 189 multiplying 3 plus 77. 189 is equal to 77 times 2 plus 35. 77 is equal to 35 times 2 plus 7. And 35 is equal to 7 times 5 plus 0. So the last non-zero number over here is 7. So the GCD is equal to 7. So GCD of 644 and 1477 is equal to 7. Now we have to check, is the GCD a divisor of 7651? So is this a divisor of 7651? And the answer is yes. Okay, so if the answer is yes, then it means that we can continue to find the solution. Now what we have to do, remember, if we get this, you have to solve the equation backwards. So solve the equation backwards. Okay, so make 7 the subject So you're going to get 77, which has 1, minus 35 times 2. So you've made 7 the subject over here. Okay, so now let's move on to the next remainder, which is 35. So make 35 the subject and plug it in into this equation. So you're going to get 7 is equal to 77 times 1 minus, if you make 35 the subject, you're going to get 189, which has 1, minus 77, 2, multiplying 2. So 7 will be equal to 77, 1 over here, 2 times 2 is 4, so you have 5, minus 189 times 2. Now let's move on to the next remainder, which is 77. So make 77 the subject. You are going to get 644, which has 1 already, minus 189 of 3. Multiply it by this 5. Then minus 189, 2. So if you expand this, you are going to get 644, 1 times 5 is 5, minus 189. So 3 times 5 is 15, plus 2, making 17. Okay, so let's move on to the last remainder, which is this. So we're going to get 7 is equal to 644 times 5 minus 1477, which has 1 already, minus 6442, all multiplying 17. So 7 is equal to 644. We have 5 here already. 2 times 17 is 34, so we have 39 minus 1477 times 17. Okay, so now that we've gotten this, you have to compare this equation to this. You have to compare this to this. Now you can see that this has 7651 to be over here, and we have 7 over here. Now since 7 is a divisor of 7651, we can multiply through by a certain number, and which number times 7 will give us 7651, and that is 1093. So multiply the equation through by 1093. So if you multiply 3, you are going to get 7. 7 times 1093, so 7651. 644 times 39 times 1093, that is 42627, minus 1477. 17 times 1093 is 18581. Okay, so now we can rewrite this to be 644 42627 plus 1477 minus 18581 is equal to 7651. And this is the same as what we have over here. So we are going to get our x naught to be equal to 42627, and our y naught will be equal to minus 18581. Now, the question asked us to find a positive pair of integers that will satisfy this equation. Let me copy this. If you remember from the last class, if we want to find x, we can use this x naught minus b over the GCD over here of a and b times t. And y will be equal to the y naught plus a over the GCD A and B times t. So x will now be equal to 42627 minus b. So the b in this case is the coefficient of y, which is 1477, and the GCD of a and b we had 7t. Y will be equal to y naught minus 18581 plus our a. A is the coefficient of x, so 644 over 7t. Okay, so 42627 minus, now 1477 over 7 is 211t, and y will be plus 92t. Now since we want pair of positive integers, we have to rewrite this. We are going to get this pair of positive integers, so greater than 0, then minus 18581 plus 92t, also greater than 0. Now let's find t in this case. We're going to get this greater than minus 42627. Now if you divide through by negative, you are going to get t to be less than 202.02. Let's make t the subject. So we are going to get 18581, which implies that t is greater than 201.97. So we have t to be less than 202.02 but greater than 201.97, meaning that t is approximately 202. Now, after getting this, we just put in back to our equations. So we know that s will be equal to, from this part, 42627 minus 211 multiplying t, which is this. So now s will be equal to 5. Now y, from this part, we are going to get minus 18581 plus 92 times 202. So y is equal to 3. Okay, thank you for watching. Like this video, subscribe and share. See you in the next video. Bye.